hear a lot of noise about and the ones that are getting bigger and bigger. But what if the real secret to make AI truly intelligent isn't just about the size of the models? What if it's a crucial behind-the-scenes skill called context engineer? Context engineering. The real secret is to building truly smart AI agents. Is not just the size of the model, but this crucial skill, as Andrej Karpathy notes. It is the delicate art and science of filling the context window with the right information to maximize the agent performance. To understand this, let's use a simple metaphor we can all grasp. Think of a large language model, the LLM, as the AI CPU and is the central processor. Meanwhile, the context window is its working memory or RAM. This limited RAM is a massive bottleneck for AI engineers. Why? Because as AI agents work reading websites, using tools, interacting with systems, every action floods this working memory with data until it becomes completely overwhelmed. When the context window overloads, bad things happen. The agent can suffer three types of failures. First, attention delusion. The agent becomes distracted and cannot focus on what is truly important. Second, performance degradation. The system simply slows down or gets worse at its task. And finally, heart failure. It's completely crashed or stops working entirely. This isn't a minor issue. Companies like Anthropic point out that complex agent tasks can involve hundreds of individual steps without careful management of what the agent is paying attention to. The failure is mostly inevitable. This is why context engineering isn't just a niche skill, it's critical. In fact, companies building the most advanced agents have to stated that context engineering is effectively the #1 job for their engineers. Not building bigger models, but managing memory. So how do engineers manage this precious limited RAM? They use toolkits based on the 4 core strategies. First, write, store important information outside RAM. Second, select, retrieve only what's needed. Third is compress, summarize oversized information. And fourth is isolate, break tasks into smaller pieces. Okay, let's dive into the first 2 strategies. The right strategy involves moving important knowledge such as temporary findings, task history, or long-term details out of limited RAM into a dedicated memory modules. Think of it like saving a file to your hard drive instead of keeping it in active memory. The select strategy then actively retrieves and pulls into working memory only what the agent truly needs right now. In this exact step, it's like opening only the files you need for your current task, not everything at once. Now for the final two strategies. To manage essential but oversized information, engineers use the compress strategy. They summarize it so it takes up less space in working memory. Instead of keeping the entire Wikipedia article in memory, you keep a concise summary of the key points. Additionally, they use the isolate strategy to break the complex task into smaller isolated subtasks. Each subtask gets its own fresh memory workspace. It's like handling one project at a time with a clean desk instead of juggling everything simultaneously. So why does mastering these 4 skills matter? Here's the big takeaway. The next great leap forward in AI isn't simply going to come from building bigger models. It's going to come from the developers who master this craft, the craft of memory management, skillfully utilizing the ability to write, select, compress, and isolate information. That's the secret to building agents that can truly scale to tackle ambitious real-world problems. As AI agents tackle problems we can barely imagine today, these 4 strategies are just beginning. It leaves us with a fascinating question. What totally new memory tricks are we going to have to invent just to keep up? Okay, so thank you very much for your attention. I'm happy to take any question you might have about context engineering or building smarter AI agents.